All right, welcome everyone to 9.3. I hope you enjoyed your spring break. Hope things have not been too crazy and that everyone's staying safe. We're going to be talking about 3 new formulas on the sheet. The 3 new formulas are the double angle formula, which are these 3-ish, the power reducing formulas, which are these 3, and the half angle formulas. And so this will come more into play tomorrow. But notice, of course, that the power reducing and half angle formulas are really just written there once. If you want to, you can write the other version when we get there. And then again, we have a little bonus for you guys. Double angle formulas. We got triple identities in one formula. So anyway, it should be a good time. All right, so we're going to be using these ones. Double angle formula, by the way. I'm not going to spoil it for you, okay? Example 0. No spoilers here. Use 9.2, the previous section, angle sum, to, there's no R there, to rewrite the sine of 2 theta, and the hint is that 2 theta is equal to theta plus theta. Okay? So we just go back and do some review. We say, okay, what was 9.2? And you may have written on your sheet, 9.2 is sum and difference formulas. All right? So we need to use the angle sum formula for sine. Plus on the top means plus on the top. So sine of 2 theta, we're going to use this. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. So sine of 2 theta, we're going to use our hint, right? That's equal to sine of theta plus theta, right? 1 theta plus another theta is just 2 of them. And then using the angle sum formula says this is going to be sine of the first times the cosine of the second. In this case, the first and second are the same. Plus the cosine of the first, sine of the second. And again, there's just theta everywhere. And then notice that sine times cosine is the same as cosine times sine. This term and this term are the same. So if we add them together, we have 2 of them. 2 sine of theta, cosine of theta. And I have to confess to you, you have just been tricked. You have been tricked into doing 9.3. I said it was 9.2, but it was actually 9.3 all along. I pulled a fast one on you. Because we just showed that sine of 2 theta, we just proved the double angle formula. Sine of 2 theta is 2 sine of theta, cosine of theta, or with use as you prefer. Okay, you could do the same thing for cosine and tangent as well. You can see how the tangent of 2 theta looks a lot like the tangent of u plus v, right? If u and v are the same thing, then on the top, we have 2 of them. If u and v are the same thing, then on the bottom, it's that thing squared. So you can directly see where these come from. And cosine is kind of a funny one, because a lot of times for cosine, we like to phrase it in different ways. So if we just use the formula, angle sum formula for cosine, we're going to get cosine squared of u minus sine squared of u. But we can use the most commonly used identity we've been using this whole chapter, the Pythagorean identity, say sine squared plus cosine squared equals 1, or sine squared, if we subtract cosine squared from both sides, sine squared is 1 minus cosine squared. And so if we use the Pythagorean identity, we can actually rewrite the cosine double identity in 2 different ways, which may or may not be helpful. So just be aware that you can use any one of these for cosine. You have freedom. Okay, so those are the double angle formulas. Let's use them. Example 1. All right, given that tangent of theta equals negative 3/4, and theta is in quadrant 2, find, part A, the sine of 2 theta. So we're just going to use the formula. Okay. Now, we're going to need a couple things here. But the first things first, we don't know anything about 2 theta. The only thing we know anything about is theta. So let's get this 2 theta out of there. Don't take the 2 out in front. Don't just double a ratio. We have to use a formula. In this whole chapter, you have to unlearn everything you think you know about functions, because for trigonometry, the only rules we know are on this page. So don't take for granted other math things. They're not going to apply here. You have to use trig. That's why this page is so important. And yeah, it's crazy how much goes away after another week. So my face-to-face class, they had 1 week of spring break and then 2 weeks of no classes. And so they're going to have 3 weeks off in the middle of chapter 9, which is really going to be rough for them. I'm telling some of them to watch these videos, but we'll see how many actually do. Anyway, we need to use the double angle formula. So what did it say? Sine of 2 theta is 2 sine of theta cosine of theta. All right, so we just write that. It's going to be 2 sine of theta cosine of theta. Great. First step, use the identity. And as soon as we do this, chapter 9 is gone. One step, chapter 9 is gone. We use the identity. No more chapter 9. We just have to figure out, well, what is sine of theta? What is cosine of theta? Well, we don't even know what theta is. We want exact. All right? Hey, Grand Theft Auto and trigonometry is a good combination, I think. All right? So if we know what tangent is, how do we find sine? We have to draw a triangle. So we know theta is in the second quadrant, so I don't know what the triangle is going to look like, but we better darn write it in the second quadrant. Okay? And tangent of that angle is -3/4. One of these has a negative, and we know it's the x-coordinate, because in the second quadrant, we're going left. Left is a negative direction, usually. 3 is positive. It's going up. Okay? Well, then, of course, we can use the Pythagorean theorem, right? 3 squared plus, be very careful, -4 squared equals c squared, and solve for that. Or you could say, I know what a 3, 4, 5 triangle looks like. Either way, solve for c, or know it's a 3, 4, 5 triangle. Hypotenuse is always positive. All right? So, well, then sine of that angle is opposite of our hypotenuse. That's just 3/5. Cosine of that angle, right? This angle is the whole thing. Adjacent over hypotenuse, -4/5. So once we find these two trig values, we just plug it in. Just replace it away. So we get 2 times 3/5, which is sine of theta, times -4/5, which is cosine of theta. And we're basically done. Just a little bit of arithmetic. 6/5, right? This is 2 divided by 1. 6/5 on the first one, -4/5 on the second one. Multiply that across, you get -24/25. Ta-da! That's our answer. Okay, so again, it's really been a theme for most of the example problems in this chapter. Use the identity first, and then it's just a bunch of other trig and a bunch of other algebra, okay? So, let's move on. What else do we have? Part B, cosine of 2 theta. Wow, what a surprise. So we just do the same thing. So you go to your formula sheet, let's see what's cosine of 2 theta, you find out, okay. There are 3 options. Which one do you use? It's up to you. Choose your own adventure. Except unlike a choose your own adventure book, 2 of these are not going to lead in your death. Okay? So you can choose any one of these. These are all fairly harmless. I would probably use one of the later 2 because that has fewer trig things in them. But you can use any trig thing you want. Okay? So, anybody have a preference on which one we want to use? We can use cosine squared minus sine squared. We can use 2 cosine squared minus 1. We can use 1 minus 2 sine squared. Okay, good choice. We're going to use the second one. 2 cosine squared u minus 1. So 2 cosine squared of u. What is u? U is our angle. It's that theta. Minus 1. Okay, and then we just kind of go back over here. What's cosine of theta? Cosine of theta we said was -4/5. So we get 2 times, be very careful, you need parentheses, -4/5 minus 1. Actually, I just realized the first identity is usually going to be a little easier for simplification purposes if you're doing it by hand. The first identity has more trig, but a little less algebra. Anyway, this is 2 times 16 over 25. We love algebra. Everyone loves algebra. We're going to need a common denominator, so let's write the 1 as 25 over 25 now. Multiply that across, we get 32. Again, 2 divided by 1, multiply the tops, multiply the bottoms. 32 divided by 25 minus 25 over 25. Subtract the fractions, same denominator. You just subtract the numerators to get 7 over 25. All right, so that's the cosine. And for part C, and again, at any point, if anyone has questions, feel free to interrupt. If in part C, tangent, remember there are 2 ways of doing this. So let's do them both ways. Say we're taking an exam and we have extra time because we studied, we prepared, we watched the videos, we emailed our instructor with questions that we might have. And so we're really doing well in this exam. We got some extra time. So we're going to solve the problem 2 ways, make sure they're the same, and make sure that we're getting the right answer. All right. And here we're kind of just doing it for practice. So remember, tangent of an angle is the sine of that angle divided by the cosine of that angle. And the angle is 2 theta. So don't get baited right here. Again, you could use the double angle formula on the top and the bottom. That would be a 3rd way to solve this problem. Don't do that. That's a lot of work. And you've essentially already done it, but you could if you want. Right? The sine, we said in part A, was negative 24 over 25. That's our numerator, negative 24 over 25. Divided by the cosine, which we just said was 7 over 25. The quick algebraist will know to cancel the 25s, but it's very dangerous to do so. Let's just quickly rewrite the division. Fraction divided by another fraction is the fraction being multiplied by the reciprocal, and that's why the 25s cancel. So you get negative 24 over 7 as our answer. And maybe this is the right answer. Maybe it's not. Let's check. We can use the identity as well. The double angle identity for tangent is 2 tangent of that angle divided by 1 minus tangent squared. So it's also equal to 2 tangent of the angle divided by 1 minus tangent squared of that angle. And again, we have to go back. What was tangent of that angle? The tangent of the angle is negative 3/4. Okay, so 2 times tangent of the angle is negative 3/4, divided by 1 times 1 minus tangent, which is negative 3/4, squared. So I think you can very quickly realize which way is a little easier to do, but we're doing them both ways because we're getting some extra practice. So the numerator becomes negative 6/4. We can reduce that later. The denominator is 1 minus, square that, becomes positive, 9 over 16. And then you get a little bit of practice simplifying complex fractions. Multiply the top and the bottom of this fraction by the LCD, which is 16. So multiply by 16 over 16. And again, if you want, you can think about this as 16 over 1, 16 over 1. So on the top, 16 on the top, 4 on the bottom, just becomes a 4 on the top. That becomes negative 24. The bottom we have to distribute. We get 16 minus, the 16s cancel on the second one, 9. Or negative 24 divided by 7, and by golly, that's the same thing. Same. Good. Smiley face. All right, if they were different, we know we made an oopsie somewhere. We goofed. A good way to check your answer right here. Okay? Any questions so far? I love the sound of paper. Okay, let's do some more. Example 1 was so fun, but we're going to move on to example 2. These ones are kind of funny. Rewrite cosine of 6x in terms of cosine of 3x. So again, I want to go on a tiny tangent, no pun intended, actually, a small tangent here to just talk about chapter 9 again. So much of these problems are just exercises. Can you use identities? And we'll use those identities to solve equations in the end of chapter 9. But really, the heart and purpose of chapter 9 is when you get to calculus, solving trigonometric integrals, integrals with trig functions. So a lot, especially in this class, especially tomorrow's video, are going to have huge applications in calculus. And I hope, is my deepest hope, that when you take calculus, you're going to see those trig integrals and you're going to say, aha, I remember doing that in Jason's trig class. And you're going to send me an email and you're going to say, hey, we used that thing you talked about. And I'll say, you don't say. And I'll feel kind of happy. All right. So remember these. These are very useful for solving integrals. Okay. So notice, right, that 3x times 2, right? 6x is just twice 3x. So we can think about this as theta, and we can think about this as 2 theta. So we're just using the double angle formula. Okay? This is double that angle, whatever it is. Maybe it's a theta, 2 theta. Maybe it's a 5 and a 10. Maybe it's a 3x and a 6x. Okay? As long as this is double of that, we can use the formula. So we're going to use a cosine form, and we can use any cosine formula we want. Let's use a different one. This time we could say that cosine of 2 theta is going to be cosine squared of theta minus sine squared of theta. Also, again, here, I love parentheses. We're writing parentheses everywhere. Capital letters, warning, right? Cosine squared of theta minus sine squared of theta is cosine of 2 theta. But cosine squared of theta plus sine squared of theta is 1. Pythagorean identity, double angle identity. They look very similar, but they're not the same. Okay, so watch out for that. Here we can write like a little danger sign. Wait, are the triangles this way when you write the dangers? Yeah, I think the triangle's this way, right? I don't know. Anyway, so let's just use the identity. So cosine of 6x is the cosine squared of, well, this is the double angle, which is the 6x. This is the single angle, which is the 3x. Okay, so cosine squared of 3x minus sine squared of 3x. And don't you dare try to use the Pythagorean identity here unless you use it correctly. If you use it correctly, you'll get one of the other forms of the double angle identity for cosine. Okay, and that's it. All right, and sometimes it can be useful in math to reduce the inside. And notice that reducing the inside, when we make the inside smaller, we get powers, which is usually worse. What we're going to do tomorrow is go the other way, where we're going to have powers, and we want to get rid of the powers because exponents are not fun to deal with in calculus, okay? So tomorrow we're going to kind of go the other way, which is interesting, where we get into the reduction formulas. All right, and that's an answer right there. That's a perfectly good answer. Another answer that would have been good would be 2 cosine squared of 3x minus 1. This is also good. Or if you wanted to do 1 minus 2 sine squared of 3x, that's good too. Look, turn the little 2 into a happy face with a giant mole, okay? So multiple answers. Just doing what the problem asks. Okay, any questions? All right, I have bad news for all of you. We have A and B, and that's it for today. So a nice little video to ease us back into chapter 9. So I have good news for you. Everyone loves verifying trig identities. So here we are. Let's verify some identities. 1 plus sine of 2 theta equals sine of theta plus cosine of theta squared. And now you have 2 choices here. Do you want to start with the left side or the right side? And neither answer is wrong, but one of them is going to be a little easier for most people. Okay? We are going to start with the right-hand side. And remember, every time you verify identities, you start with the hard side, and move to the easy side, or start with the side that you start with the side that you can see something to do with it. Left-hand side, I mean, I've taught trig for a while, so there are things to do with either side. If you see, on the left-hand side, we can use the double angle formula for sine. You can do that. Once you use that, you might run into a dead end. And if you ever run into a dead end on a verification problem, go to the other end. Okay, this is a two-way street. If you get in a dead end over here, start looking at this one. I think for most people, the right-hand side is going to be a little easier here. So the right-hand side, remember, we have to FOIL this out. This 2 does not just distribute in because this is a binomial. It's not technically a binomial, but it's 2 terms. Okay? All right. So we have to FOIL this out. Shortcut is the first thing squared plus double their product plus the last thing squared. If you don't want to use the shortcut, you want to FOIL this out the long way, go for it. And now we say, well, Jason, this looks nothing like the left-hand side. But you see a sine squared, your ears perk up. You see a cosine squared, your mouth starts watering. You've tasted this before and you want to taste it again. Sine squared of theta was so weird. Sine squared of theta plus cosine squared of theta is equal to 1. Right? That's a Pythagorean identity. So we have 1 plus 2 sine of theta, cosine of theta. All right? And you say, okay, they each have a 1 here, but these aren't the same. If you said that out loud to me, I'd cut you off and say, no, you are wrong. These are the same. This is the double angle identity. Sine of 2 theta. What is that? Sine of 2 theta is 2 sine of theta cosine of theta. We just immediately use the double angle identity. And there we are. In 1, 2, 3 easy steps. Easy's relative. Don't box this. This shouldn't be boxed. I'm just getting excited. It's like Christmas time. Okay? Doing math is like Christmas. And that's all there is. Last example of the day, unless people have questions. Part B, tangent of 2 theta equals 2 divided by cotangent of theta minus tangent of theta. All right, I'm going to be honest with you guys. When I prepare these lectures, I don't look at the answers. If I don't see the answer, it gives a good opportunity to figure it out together. So you could start with either side. Let's brainstorm this. The harder side is certainly the right-hand side. So we could start with the right-hand side, just as a general rule of thumb. Go for it. But you can actually do something with either side. On the left-hand side, we could use the double angle identity for tangent and get 2 tangent of theta divided by 1 minus tangent squared of theta. On the right-hand side, we have a cotangent. Reciprocal functions, we usually like to undo those. So we could undo the reciprocal function in a variety of ways. So ways to start with either side. Let's start with the right-hand side, since we usually start with the messier side. So what are we going to do with this? 2 divided by cotangent. You have 2 options. One option is to put everything in sines and cosines. And that'll work. Okay? In this case, I kind of want to show it both ways. There's a bunch of different ways to do this problem, and they'll all get you to the right place. We have time. We're going to do it both ways. Okay? So let's put everything in sines and cosines. Cotangent is cosine over sine, minus tangent is sine over cosine. Complex fraction. How do we get rid of complex fractions? We multiply by the LCD. The LCD is sine of theta times cosine of theta. So on the top, well, that's easy. 2 times that is just 2 sine theta cosine theta. Again, alarm bells going off in the head. Ding, 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 ding. 2 sine of theta cosine of theta. That's a double angle identity. This is sine of 2 theta. But just recognize it. Maybe we don't want to do that. You don't just plug in identities everywhere. Identities are not just this river that just gushes out uncontrollably. You have to choose. Do I want to use this identity here? Why? Why not? So let's just wait. But see it. Okay? That's great math. That's great math teaching right there. Just see it. Just know what it is. Okay, and on the bottom, we have to distribute. When we distribute to the first thing, the sine is going to cancel, and we're left with sine times cosine, which is cosine squared. On the bottom, ooh, this is good, this is good. We distribute now to the second one. The cosines cancel, we're left with sine times sine, sine squared. Ding, 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 alarm bells. Okay? This also looks familiar. It looks like no, it doesn't, Jason. It's not the Pythagorean identity because Pythagorean identity has a plus. There was something else that looked similar to Pythagorean identity. Ah, yes. The double angle for cosine is when there's a minus. Yeah, I got some of you, I bet. I'm out of control today. The bottom is cosine of 2 theta. Well, wait a minute. If the top is sine of 2 theta and the bottom is cosine of 2 theta, what's sine over cosine? Oh, tangent. Okay, so we got sine of 2 theta over cosine of 2 theta using the identities, which of course is just tangent of 2 theta. And if you don't like check marks, if you think check marks are a little boring, you can give a nice little smiley face. This is a happy trig man or woman, kind of uncertain gender. Okay? So, yeah, add some parentheses around it. All right. So we could have done it a bunch of different ways, right? Real quickly, this is the end. Real quickly, or, I'm not talking about Oregon. Another way you could have rewritten the right-hand side is say, I don't like reciprocal functions. How do you undo a reciprocal? You multiply by the reciprocal's reciprocal. That sounds confusing. But if we multiply the top and the bottom by tangent, it also would have worked. The top, we would have gotten 2 tangent of theta. The bottom, when we multiply, tangent times cotangent, they're reciprocals. It's just 1. Minus tangent times tangent is tangent squared. And oh my goodness. 2 tangent of theta divided by 1 minus tangent of theta. That's right here. Oh, that's already... This is the easiest problem in the world. Jason, when are we going to get some hard trig problems? And so again, notice, this way took longer. This way took shorter. That's okay. When you're taking quizzes or exams or doing homework, do not freak out about what's the fastest way to do these. There's a whole bunch. You just have to get there. Kind of like degrees. You know, it doesn't matter if you take 10 years to get a degree or 5 years. What matters is that you get the degree at the end of the day. All right. Math is kind of like that. Doesn't matter if you go the long way or the short way. Just do it. All right. So we could have also started with the left-hand side. Again, options galore. I love these verifying problems. Anyway, that's pretty much it. Tomorrow we're going to start about the reduction and the half-angle identities, which again, spoilers, are the same identity. Okay, but we'll get into that later. Anyway, thanks for watching, and I'll see you tomorrow.